Hello everyone. In this video I'm just going to be talking very quickly about how to rearrange simple equations. Now the reason I'm doing this video is because a number of my students, when faced with a particular scientific problem, whether it be biological or looking at chemistry or given a physics formula for example, they're able to do a very straightforward calculation if the formula that is presented is quite easy to work out with a calculator perhaps, but sometimes when you need to rearrange that formula, some students I know have a little bit of difficulty working out whether they're dividing or subtracting and what's moving where. So this is very simply just to highlight a few quick tips when looking to rearrange a simple equation. So let's just take the format A equals B plus C. And we're going to substitute these letters into actual things that you'll study in science in a moment, but we're just going to keep it straightforward like this. So we've got A equals B plus C. Now, the trouble may lie when we want to identify just B, when we want to isolate B on its own. Now, when we want to get a value on its own, what we need to do is basically get rid of everything that is happening to that value, if you like. And by getting rid of it, what we do is actually send everything to the other side of the equal sign. So if we imagine this equal sign here being almost like a bit of a wall like that, we look at what's happening to B and we need to get rid of everything that is on that side. So for example, we've got B, and let's say that is our end game. This is what we want to find out, what B equals. So we said A is equal to B plus C, but we want to know what B equals. Well, we can see that we are adding C to B. So what we need to do is get rid of that C, if you like, and send it to the other side. Now there's a few quick rules, if you like, with rearranging equations. If we just make a note just for a moment on the side, plus and minus go together, divide and times go together, and a value, I'll just put a question mark, squared and square root go together. So you're almost doing like the opposite one when you send it onto the other side. So here in this example, A equals B plus C, we're adding C to B. So when we send it over to the other side, we have to do the reverse. So instead of adding this time, it becomes a take away. So if we send C onto the other side, what we end up with is A minus C is equal to B. And that's what we wanted. So we're adding C on the right hand side, but when we take it over we have to do the opposite, which is minus C. So you can also do, if we wanted C on our own, for example, then you can see that to C we are adding B. So if we take B across, we need to be minusing B. So if we wanted C on our own, we could also say that C would be equal to A minus B. Let's change the equation at the moment from the top. So we had A equals B plus C. What if we had A equals B times C? Well, in this example, let's say again we want to find B. So we look at what's happening to B and we can see that we are timesing or multiplying it by C. So if we send C onto the other side this time, the C needs to be dividing. So what we'd get is B equals, and we've got the A, but this time divided by C, because what we've done is take the timesing by C and we've sent it onto the other side, and it has to do the opposite. So instead of timesing by C, we're going to divide by C. Remember, we look at the thing we want, which in this case is the letter B, and we get rid of everything that's happening to B. So instead of multiplying by C, we take it onto the other side, but when we take it on the other side, it does the opposite, so it will be a dividing. And equally, we can rearrange this to get C. So C would be equal to, and again, C is being timesed by B, so we need to take it on the other side. So B this time would be dividing. So C is equal to A divided by B. Let's put this into a real context. So let's this time talk about one of the equations we see in physics, speed. Speed is distance divided by time. So let's just put this down here. Speed is equal to distance divided by time. If we were to use the correct letters, we'd say that S is equal to D divided by T. Now in a simple calculation that's fairly easy to do. If we had a distance of 100 metres, a time of 10 seconds, our speed would be 10 metres per second, if we were to work that through. But if we wanted to get distance on our own, then we can see we look at what's happening to that letter D, and we can see we are dividing it by T. So we need to get rid of the T. So what we can do is take the T over to the other side, and whilst T on the right hand side of this equation was dividing, it now would be timesing. So if we have that S and times it by the T, that would leave D on its own. So we've had speed is equal to distance divided by time. Distance is now equal to speed times time. And if we wanted times on our own, then we can look at this equation we've just done here, and we can see that to get T on its own, we need to get rid of the S, and the S is multiplying by T. So to get rid of the S, we need to send it on the other side and have it dividing. So in this case, we'd end up with time would be distance and then divided by speed. So what we've done there is rearrange that one simple equation, and we can work out what speed is. We can work out what our distance is. If we want to, we can work out what time is. So let's think of some other examples as well. So just shrink the screen for a moment. Just bring this up. Just two more particular formula, for example. So let's think about, so in this first example, let's think about voltage or potential difference. So the formula is V equals IR. Now sometimes when we have two letters next to each other like that, what it means is multiply. Sometimes the times sign isn't shown. So this means PD, or the voltage, which is represented by the letter V, is equal to the current times resistance. So we think about electric, or the flow of electricity, rather. So the voltage equals to the current times resistance. So if I wanted to find out what I is on its own, I would take this R, and I would need to send it on the other way and have it dividing instead of multiplying, which it's doing at the moment. So I on its own would equal V divided by R, and equally if I wanted I, or R rather, on its own, I would get rid of the I to the other side. So R would equal V divided by I. So very simply, we've rearranged to isolate not just the voltage on its own, but we've now got current on its own and also the resistance on its own. Let's think of a second example. So acceleration is equal to V minus U divided by T. V is final velocity, U is initial velocity, and T is time, because acceleration is defined as the change in velocity divided by time. So if I wanted to find V on its own, so if I wanted to just get V on its own, what I would do is send the T across. So T is dividing in this case on the right hand side, so it's got to times when we send it over to the left. So we could put A times T would equal V minus U. And if we want V on its own, remember, we need to get rid of the minusing U part. So on the right hand side we're subtracting U, so we need to add it on the left hand side. So V would now become A times T, we can put that little part in a bracket, plus U, because what we're doing is sending that U over to the other side, and on this right hand side it's being subtracted, so we need to add it when we send it over the other side. And that there, it's a very simple way of rearranging that equation to find the particular value we want. The same would apply if we had a value that's being squared. So when you take the, if you want to find, for example, and we'll just do this one last example. So this will be our third example here. if I said a squared was equal to b, just random letters there, a squared equals b, and I want to know what a is, I need to take the square sign almost like send it the other way. And when I'm not squaring, I'm then square rooting. So it becomes a square root. So a on its own this time would be the square root of b, and that's how I can find the value of a just on its own. So there we have, very simply, how to rearrange quick equations to get the particular value that you want. Now, some people I know play around with these kind of triangles. If I just put one here. So if I go back to the speed, distance and time thing, some people have these kind of triangles like that. And you say if you want speed, you almost imagine putting your finger on top of the letter S and you cover it up and you'll see what's left. So if we did that, we'd get a D, and this line here is a divided by. So we'd get D divided by T. If we want distance, if we covered up the D, you can see it's speed times time. And if we put a finger over the letter T, you can see it's D divided by S, distance divided by speed. So there is this method. You could use this particular triangle way of doing it and you put sort of values in there, but it's much better if you can understand why things are as they are when you rearrange, why you subtract or add or times or multiply and divide instead. But I hope that helps.